Hello everyone, welcome to the final project presentation of spring semester 2024. Here is the title of my project, which is Performance Evaluation of Multilevel Inverters, a Comparison Cascade H-Bridge Topologies for 7 level, 9 level and 11 level. My name is Imtiaz Reza Hamid and here is my ID, which is 202388574. Here's the outline of my project presentation. First, I will give a short introduction of this project, then I will discuss the topology, then I will show the MATLAB Simulink implementation, then I will discuss the results, and finally we will have the conclusion. Here comes the introduction. In recent years, the demand for power electronics has been surged, driving advancements in power conversion technologies. A key innovation in this field is the inverter, a device that converts direct current to alternating current. Multi-level inverters, which offer significant advantages over traditional inverters, are now essential in medium to high voltage applications, such as motor drivers and power distribution. Multi-level inverter technology works by connecting capacitors and semiconductor devices in series with one or more DC sources to generate stepped voltage out uh, waveforms. These waveforms closely resemble that ideal AC waveform, reducing the harmonic distortions and improving power quality. Among various multi-level inverter topologies, the Cascade H-Bridge inverter stands out due to the simplified design and efficiency, requiring fewer components to achieve the desired voltage levels with total harmonic distortions, which is also known as THD, and it also reduced the switching losses. In this project, we focused on the Cascade H-bridge topology, which can also integrate renewable energy sources like photovoltaic arrays, and by utilizing pulse width modulation techniques, and the inverter's output can be preciously controlled, further enhancing the performance. Here comes the overview of Cascade H-bridge multi-level inverter. As I have mentioned, it is a simplified topology with fewer components, and it has the lower harmonic distortions even without the filters, and the switching losses are fewer according to the conventional one, and it consists of a H-bridge, which also consists of 4 switches and diodes, and it's capable of producing 3 voltage level outputs, which is positive, negative, and 0. And for the output voltage calculation, we use the formula, which is twice k plus 1, where k is the number of cells. And if we observe the output waveform, it is a multi-level staircase waveform, which approach to the sinusoidal shape. And I have also discussed the applications of the multi-level inverter. Here comes the topology. The Cascade H-bridge multi-level inverters contains multiple H-bridges. As I have mentioned earlier, it uses 4 semiconductor switches such as MOSFET and separate DC voltage sources, produces voltage levels ranging from positive to negative. And as I have discussed the formula previously, so for the output voltage equation, if we assume that VO is the output voltage, then it will be the summation of the voltage levels, which is denoted as VO1, VO2, VO3, Vm, where VO1 is the output of first H-bridge, VO2 is the output of the second H-bridge, VO3 is the output of the third H-bridge, and the Vm is the output of the nth H-bridge. For the topology, we have the switching modulation techniques such as sinusoidal pulse width modulation technique. It compares a modulating sinusoidal wave with a carrier wave, which requires n-1 carrier signals for an n-level inverter, and the gate pulses regulate switching in H-bridges. Types of SWM techniques. The first one is phase shifted modulation technique. The second one is level shifted modulation technique. For the first one, it has n carrier signals phase shifted by 180 divided by n. For example, for 7-level cascaded H-bridge multilevel inverter, shifts occur at 0 degree, 60 degree, and at 120 degree. Results: higher switching losses, significant harmonics. And for the second one, level shifted modulation technique, it consists of twice n carrier signals vertically separated. Example, 6 carriers for a 7-level output, and it results reduced switching activity in each cycle. Only one module changes state. As we have started from the 7-level cascaded H-bridge multilevel inverter, here is the basic schematic diagram for the circuit. Here we can see we have 3 H-bridge cells which consist of 4 MOSFET, and which is denoted in this schematic as S11, S12, S13, and S14. And we have 3 DC voltage source for the 7 level, which is denoted in this schematic as VDC1, VDC2, and VDC3. And we will have the AC voltage in the output end, in the PQ end, so which will have the 7 level of the voltage. Here's the implementation of the 7-level inverter on MATLAB Simulink. The figure is shown for the circuit, and the switching modulation technique for 7-level inverter is also shown in this figure. As we have discussed, we will have some carrier signals. So first we have used a reference sine wave, then we have used another inverse reference of that sine wave, and we have given some repeating sequence for switching, which is denoted in the figure repeating sequence 1, 2, and 3. And here is the implementation for the 9-level cascaded H-bridge multilevel inverter on the Simulink. It is also same as the previous one. So as we have mentioned that it is a 9-level inverter, so it will have 4 H-bridge cell, and for that we will have 6 reference signal for the switching. And here is the implementation for 11-level cascaded H-bridge multilevel inverter on the Simulink. As it is a 11-level, so we have 5 H-bridge cells, and that's it. Here is the results for the 7-level cascaded H-bridge multi-level inverter. Uh, this figure illustrates the output voltage and currents. From there, as we can count, it has 7 level, and for that we also have calculated the total harmonic distortions for the output voltage, and which is 13.52%. And here is the results for the output voltage and current of 9-level inverter. And the voltage is the red one and the current is the blue one. And for that we also have conducted the simulation for total harmonic distortions of the output waveform. So as we can see, the output in the output waveform, the total harmonic distortions also reduced in the amount of 10.23%. Here comes the simulation results for 11 level. As we can see, for this one, the total harmonic distortions is 8.41%, which denotes if we increase the level of the voltage, the THD will reduce into a certain amount, which is good for the appliances. And it is a figure of gate pulse of the switches for 7-level cascaded H-bridge multi-level inverter, as we have used 12 switches for the 7-level. So we have 12 gate pulse for the circuit. Here comes the conclusion. The project has extensively analyzed cascade H-bridge multi-level inverters and a detailed exploration of CHP MLI, which is known as cascade H-bridge multi-level inverter levels, and sinusoidal pulse width modulation technique. Simulation studies conducted for 5-level, 7-level, 9-level single-phase inverters, and it is also demonstrated that the THD decreases as the inverter level increases. As I have discussed earlier, that we have the 13% THD for 7-level and 10.23% for the 9-level and 8.41% for the 11 levels. So, which results increasing inverter's level requires more component and a larger circuit, and which also includes the benefits by reducing the switching frequency and losses, which also help to enhance the efficiency, especially in high voltage applications. And here is the reference for this project. Thank you, everyone.